Hello, my dear friends. I'm back with a new video today, and in this video, I'm going to talk about a very interesting topic, which I mentioned in my previous video that I'm going to cover the Kaveri 2.0 engine development program in details in a separate video. And today, in this video, we are going to cover that. Um, Apart from that, I have been getting quite a few requests regarding the covering about the spice jet uh, issues that are doing around in the media, and what is the impact of that for the aviation industry. So I will cover that in a future video. I'm not going to cover that in this video because we are going to dedicate this particular video for this very interesting topic on Kaveri 2.0 and its backstory, and also you know uh, uh, people say that India has developed its own aircraft carrier, its nuclear submarine, the nuclear reactors, and also we reached the far side of the moon. But why this has been such a uh, you know difficult and critical challenge for us to move past? So I'm going to talk about in detail about why uh, the engine technology is one of the uh, most difficult and challenging technology, and how we are going to do that in future, and how India is going to become the real self-sufficient in that aspect as well. So we are going to cover all that in this video. So with that, let's move to the detailed discussion, and let me start with a little bit of backstory about the Kaveri engine. So, people who might not be aware of what this Kaveri engine is. So, for them, let me just give you a quick brief about what this is and when it started. So, as many of you might be knowing, that in 1983, India started its own indigenous combat aircraft development program, which was the LCA Tejas. And for the LCA Tejas, India also started its own engine development program in 1986. So that engine development program was named, or the engine was the uh, the engine was named GT 35X, but the program no, sorry, GTX 35A, and the program was named as the Kaveri engine. So Kaveri engine was supposed to power the indigenously developed LCA Tejas. However, due to a lot of challenges in terms of technical challenges, the metallurgical challenges, as well as some of the crippling uh, accessibility challenges which happened later on due to some of the sanctions and all that stuff. So GTRE was developing this program, but were also facing the challenges on developing uh, the the core of the engine. What we what we mean that core of an engine is basically its hot section. The hot section is basically its combustion chamber, where actually the gases get uh, burned, and then the hot uh, jet of gas comes out of that uh, that combustion chamber, and falls on the high pressure turbine, and then it goes through the low pressure turbine. So this uh, uh, high pressure turbine and the um, combustion chambers, so these are some of the very very critical component of the aircraft engine. So we'll talk more on that. So this story goes like this, that so ultimately this engine development program faces a lot of hurdle, and it kind of failed to deliver. So the test engine, which was being developed by the gas turbine research establishment GTRE in a part of DRDO. So they uh, you know could not develop that program or that engine in time. So later on, what happened was that also the uh, HAL, which was building that or manufacturing, going to manufacture those LCA Tejas aircraft. So they decided to go with the uh, a known trust kind of trusted and tested engine, which is GE F404 engine. Those engines are some of the highly used engines, like uh, they are being used for F-18 and some of the other aircrafts globally. So that's a very very known uh, trusted and tested engine platform. So that's the reason why this LCA Tejas went for GE F404 engines, and even the current version of LCA Tejas and also the Mark 1A are powered by F404 engine. And you all of you know that what kind of challenges that we face because of GE not being able to provide the engines in time, be it earlier uh, the COVID related supply chain issues, or now whatever the delays, and now also the F414 engine, which are supposed to uh, power uh, the Mark 2 Tejas Mark 2 variant of the aircraft. So the asking price of that has also gone up. So that's exactly where the government and the research organizations and everyone felt that this is right time to start working on this Kaveri 2.0. So what is going to happen with the Kaveri 2.0? Basically, it is being worked on a very very focused manner, with I would say on war footing, that the development is going on. And the idea is to develop the dry thrust of 55 to 60 kilonewton, uh, which is very similar to the F404 engines, and then have the wet thrust, that is with the afterburner, so about a wet thrust of about 90 kilonewton. So that is the development and the goal that Kaveri 2.0 is working on. The dry engine is going to be also used for some of the UCAV programs, like so the unmanned uh, combat vehicles, so like the Ghatak. So where this dry engine is going to be tested, or the real time testing will also happen, and the development refinement will also happen. So the idea is basically to develop this Kaveri 2.0 into a 90 kilonewton wet thrust engine, which can not just match the 84 kilonewton thrust provided by the F404 GE F404 engine currently used for LCA, but all even more thrust than the current engine, and also reduce its weight, so that the overall engine weight can be restricted somewhere around 1200 kg. So basically that will help the aircrafts to have better thrust to weight ratio. uh, and you know when the earlier version of LCA Tejas goes for their midlife replacements and refits, so somewhere around mid of 2030s. So that's when this Kaveri 2.0 engine can be used and replace the existing F404 engines, and then eventually move to a higher thrust engine of 120 to 140 kilonewton, which will then power the AMCA as well. Though HL is working closely with uh, organizations like Saffron, and also recently the the Reliance and Rolls Royce have tied up and uh, did a press release about their intention to work on this area. So that's a great, I would say, development that are going on. That we are seeing a lot of development activities and uh, tractions from India and some of the other uh, well-known global organizations. But ultimately, the idea is to design, develop, and have India's own engine in India, so that we do not have the strategic dependency on any of our other countries. So which you can see that LCA is already suffering from. Uh, we know that about 30 LCA has been manufactured and sitting on the tarmac and want of the engine. So these are major challenges at the time when the aircrafts are or I would say the air force's squadron strengths are going down, right? So we need more and more aircraft faster, so that we can replenish those squadron depletion, because we need more squadron strength to fight a two front security challenge. So that is the requirement, and I think this Kaveri 2.0 development is now focusing and moving in the right direction, and we really hope that this will help in reaching that strategic independence for India. Now, let me quickly touch upon why this is such a challenging technology to overcome with. So as I said that the engine core, which is basically the hottest section, so you would be amazed that the temperature in those section is somewhere around 1600 degrees Celsius. So any known material um, to humankind uh, cannot withstand that kind of a temperature for a elongated time. So obviously there are metallurgical research that has happened, and obviously a lot of different materials and the thermal barrier coating materials have come up over the years. And now the challenge here is it's twofold, not just the material or metallurgical challenge, but also uh, the airfoil design that happens for the turbine blade. So those are those single crystal blades for the turbine blade. So that is another very fine, most precision uh, manufacturing and development. So, and it has a particular cooling hole configuration. It has certain specific serial of its how it is being developed and placed in the disk and all those stuff. So a smallest to smallest mistake in that process can damage uh, the blade, and not just damage that blade, that blade will just fly off and will damage the other blades and other sections of the engine, like low pressure turbine or the afterburner and the nozzles and all other sections. So obviously that engine will uh, get completely destroyed. So a smallest mistake, a smallest quality issue, a small design problem can create huge damage of destroying that entire engine. And imagine that you are flying in an aircraft uh, where you will be flying at a very high speed, somewhere like 1.5 to 2 uh, times faster than and faster than sound. And suddenly if your engine behaves wrongly, so that is the last thing that you want, right? So and remember that engine technology is aircraft engine technology or jet engines are the most complex engineering uh, technologies in the world that uh, that only very few countries have been able to master so far. And India is really progressing in the right direction. And what I would say that we are uh, moving to the direction of developing. We already have designed, but now this Kaveri 2.0 is a complete redesign, so it's not that incremental changes from the previous engines. So we have learned from those mistakes. We have learned from all our journey so far, and completely redesigning, completely redeveloping those engines. So you can only expect that we are going to become a real strategically independent in the engine technology as well very soon. uh, Probably in next 5 to 7 years we would see a lot of uh, you know news and improvements and testing that are being talked about those engines. So with that, I leave the story here, and I would be very happy to cover more in details about the different technologies and different areas on the technology development, and who are working on that, how we are working on that. So we can definitely discuss more on those in future videos. But for now, I think this is good enough. And with that, have a great day. Thank you.